Welcome to myprojectbazaar.com.
The project title is Maximum Eigenvalue-Based Sensing and Power Recognition for Multi-Antenna Cognitive Radio System. The project abstract is we propose the corresponding detection or recognition framework based on multiple antenna configuration at SUs. The secondary target appears in order to identify PU's transmitted power level once the PU is detected in the first place. To achieve these two targets, an eigenvalue-based approach is applied due to its robustness and least requirement on the knowledge of channels. We adopt non-asymptotic Gaussian and gamma approximation for the distribution of eigenvalues of the sample covariance matrix. The project flow diagram is to calculate the maximum eigenvalues based on the multiple antenna system. Initially, we create a system model for cognitive radio networks. Next, we have to sensing the and recognizing the primary and secondary user to calculate the maximum eigenvalues. Next, we detect the primary users for receiver side by using MPTP, that means multiple primary transmit power. Next, we have to recognize the transmit power for primary users. Finally, we calculate the performance measure for maximum eigenvalues and detection probability. Our project source code file was run from the command window. In current folder shows the many files. In our source code file was stored in the main.m. So we have to run the main.m file. It is our overall results for our process. In workspace shows the many variables name. In that variables are used in our source code file. It is to calculate the variables of our source code file to measure the values. It is up to minimum and maximum values are shown in the workspace values. In figure 1 shows that the cumulative distribution function of maximum eigenvalue. In X label shows that the eigenvalues, and Y label shows that the cumulative distribution function of the maximum eigenvalues. In red color line shows that the receiver side of our primary users. It is a different form of our users are transmitted through the cognitive radio networks. In figure 2 shows that the Gaussian or gamma approximation with SNR. In X label shows that the NS, and Y label shows that the detection probability. When the detection probability of primary users are varying to the receiver side, in blue color lines are shown that the P distance of Gaussian approximation, and red color line shows that the probability of gamma approximation. In figure 3 shows that the decision probability with different NS. In X label shows that the NS, and Y label shows that the decision probability. It is the line for our primary users. In blue color line shows that the probability of Gaussian approximations. It is the H0 and H1 values. In figure 4 shows that the detection or discrimination probability. The NS value is 3000 means like that the curve will be drawn. When the NS value is 10,000 means the curve will be like that. There are two types of approximations are there. First one is Gaussian approximation and second one is gamma approximations. It is probability and distance can be calculated. In figure 5 shows that the probability of detection versus SNR under Gaussian or gamma approximations. Where the NS value is 3000 means the simulation curve will be like that. Where the NS value is 10,000 means the simulation curve will be like that. So like that the Gaussian and gamma approximation for NS values. In X label shows the SNR and Y label shows that the probability of detection. In figure 6 shows that the comparison graph for probability of detection versus SNR under Gaussian or gamma approximation. Where the ns value is 3000 means the simulation curve will be like that. The ns value is 3000 means Gaussian and gamma approximation curve will be like that. Where ns value is 10,000 means the simulation of and Gaussian and gamma approximation curve will be like that. In X label shows the SNR and Y label shows that the probability of prediction. The project demo was completed. Thanks to watching this video.